All right. Welcome to the first day of Linux installation and configuration. Yay. We made it. We made it. I'm your instructor, Leo Chavez. Aha. Yeah. Written here. You can find me, obviously, if you look at the clock. It's during this time right now. Wednesday 10 to 12, Wednesday 2 to 5. So after we do all of this, we'll take a bit of a break. I'll come back at 2 o'clock, so if you have questions or anything like that, feel free to come back into the class or come back into the WebEx session. Just click here to get logged in. And yeah, join me. Ask questions, hang out, talk about Linux or whatever else you want to talk about. I used to teach all of the, pretty much all of the classes. So if you have questions in your other classes and you need a quick answer or something like that, and it just happens to be office hours, feel free to swing by. If I don't know it, I'll take a swing at it anyway. It's all about the confidence, right? And then Thursday, again, 2 to 5. This time is reserved for everybody, I guess. This really is just kind of wide open office hours. So folks from the computer virtualization class might swing by in this during this time as well. But this is not the only time I'm available. I mean, obviously, you can email me anytime during the week. I try to respond as quick as I can. Email me here. Oh, wait, hold on. I know it'll highlight. There it is. Email me here. And yeah, you can hit me up in Google Hangouts as well if you prefer that more chatty style, asynchronous chat. And then if you prefer the phone, give me a call here. It's all there. And it's all here as well. So it's almost impossible to miss my information. Almost. Maybe you got a quick scrolly finger. Anyway, so a couple days ago, you probably got my announcement. I assume if you check your email regularly, this thing. And really just to get everybody started, a quick intro kind of thing. So yeah, pretty much everything I've said so far, just ping me. The package management unit was open on Monday. And I just want to throw this out there. And it'll be every week. Every week will be like this. I'm going to open stuff up on Monday. The way that everything is scheduled out, it gives you the first 2 days to kind of skim over it, read the notes, get an idea of what we're talking about. Then we'll come together like today on Wednesday, and we'll talk about it all. I'll go over all of the stuff. If I need to show you anything, and I will every single week, I'll need to show you something. I'll show you that on these Wednesdays. Everything will be due Sunday 11:59. So you get all week. Sunday midnight really is what that turns out to be, but just to be explicit, yes, Sunday 11:59. Maybe it's just me that when I think about 12 a.m., I'm like, is it 12 a.m. the previous day or the next day? Yeah, this way I'm not confused. Maybe it helps you out too. So yeah, this class first couple hours on Wednesday when we meet. That's when we'll do this recording stuff. And I'll make it available to you. So I record this, make it available on YouTube. That way you can get subtitles and all that other kind of stuff without too much fuss. And yeah, you can speed me up or slow me down. I've had people tell me that I talk kind of fast, so you may not need to speed me up. But sometimes these videos go a little long. So instead of speeding me up, maybe you can just pause me. That might work well. A lot of times we'll come up to commands and things like that go by pretty quickly. That's where the pause button comes in really handy. Anyway, attendance. This is pretty big. If you have done anything in the class, I try to make this easy. A lot of the instructors tend to do like a syllabus quiz or a show no show quiz or a do something specific in the class before I can count you as present quiz. No, I don't do that. What I do is if you have logged into the course and clicked on anything at all, anywhere, doesn't matter. If you've opened up the notes, if you've watched the video, if you have opened the quiz, if you have opened the lab, if you have submitted something, anything that you have done, if you have done anything in this class, I can take a look at that. And at the end of the day, every day, I update your attendance to be a show or a no-show. So you don't physically have to do anything other than come into the class. So if you've logged into Moodle, clicked on the class, the Linux class, you are present. So nothing too much to do there. All right. So that's that. Just in case you didn't get it, now it's recorded and you can't say you didn't hear about it. QA forum, if you have questions, if there is anything that comes up that I guess you feel like is something that everybody needs to see, feel free to put it there. For everything else, right, you can direct message me. A lot of times what will happen is if I need to change something or if there's something I need your feedback on, that's where I will put this stuff. The announcement doesn't let you respond in that forum in line, but the QA forum will. So I'll put things where I need your input down here. And again, if you have a question that maybe other students might need to put input on, that's a good place to put it. That way it's nice and centralized and everybody can jump in and say something about it. Course overview, it's basics of what this class is about, but I think the title does it justice. It's Linux. We're going to dive into all of the nitty-gritty Linux. I apologize. It's probably not going to be a lot of GUI in this. And GUI, if you don't know, is the graphical user interface, right? The mouse. There will be very little mouse moving and very little Firefox launching or Chrome launching in this class. Pretty much all of it is going to be how to interact with a Linux machine with a keyboard. A lot of it's going to be commands. I get a lot of groans and a lot of, oh, this is going to be so horrible. And well, it's not Windows. It's not, there's no GUI here, right? I mean, there's no control panel. There is no update panel. Everything is done by some kind of invoking of magic, basically. And yeah, I'm here to teach you how to do all of that. So while it is different, it may not be worse. I've over the years I've kind of come to the conclusion that it's half and half. Some things are just way easier to do in the GUI, and some things are just way easier to do in the command line. And I kind of sit on both sides. So yeah, hopefully I can maybe pull you at least on your opinion of one thing. Maybe one thing you'll give me the wink and the nod and say, yeah, okay, that's fine. That's easier in the command line. So that's my hope. We'll see how it goes. Syllabus, in case you want to get the official word on anything, that's all there. Syllabus in PDF form, syllabus in written form, like written out form in Moodle form. They're the same thing. The student handbook, the stuff that is the rules when you come onto the campus, which is probably not going to happen much. And, submitting homework, plagiarism, all that crazy jazz. You have likely heard all of this before, so I will spare you the speech this time. How to use Moodle. Again, I figure you're probably in your second or third semester, so you have a good idea of how all this works. But just in case you need a refresher, there's this. What to do in case of technical difficulties. The short answer to this is email me. Now, if I guess that would present a problem if your phone and your laptop and your desktop and your other laptop and your parents' desktop and your sister's desktop and your brother's laptop all sink into the lake on a boat. They were all on a boat at one time, and they all sink, and you got nothing. Yeah, I guess that would make it difficult, but you can likely get to an email of some kind of internet to email me, hey, catastrophic craziness just happened. Just keep me in the loop. That's really the idea with all of this stuff. Just keep me in the loop, and we can work something out. Email and voicemail. I swear they just dropped this into everybody's class. Just take a look at this. The idea is like no leet speak, no text speak in chats and whatnot. So yeah, take a look at that. Same with discussion etiquette. It's the same kind of deal. So yay, the meet thing. You probably have this in almost every single one of your classes. Grown-worthy stuff, right? But just throw your information in there. I really do kind of would like to know the answers to some of these questions. We had kind of talked a little bit before I hit the record button about favorite Linux distros, stuff like that. So yeah. So on what topics are you most interested in? Have you even heard of Linux before? that I think, I don't know, as an aspiring IT person of some kind, I imagine you've probably heard the word Linux. But in that vein, if you hadn't heard of Linux before, hopefully you're at least slightly interested in it. Otherwise, this might be a bit of a slog. But yeah, so what's your experience in Linux? If you've actually heard of it before, what have you done? What have you done with it? Do you run your own Plex server so you don't have to deal with Netflix's jazz? Interesting stuff like that. Right, I think Linux is pretty important in, I don't know, all the time, everything. I think Linux has gotten its grubby little hands all over all of the network infrastructure. There's tons of stuff now that is based on the Linux kernel. Even Cisco has a weird modified Linux kernel in some of its hardware. So it's everywhere. You can't get away from it. So yeah, no matter what you do, no matter how you do it, pretty much all of the intrusion prevention, intrusion detection, stuff like that's based on Linux and Linux packages. Routers, IPFire, pfSense is not a Linux, but it's BSD, and they're very related. And yeah, tell me a little bit about you. We don't get to do the face-to-face thing at all. I get to maybe see you in a little video box. That's about as close and personal as we get. So yeah, this is probably the only way I will get to know anything about you outside of taking a look at the wallpaper that you have behind the VM when you send me a screenshot, and maybe we can strike up a conversation about that. But that's probably as close as we're gonna get. So yeah, share me something. Tell me a little bit about you, about what's going on, and yeah, do you hate Linux? Answer that question in there somewhere too. That would be kind of nice. All right. Well, that's all the intro stuff. You now know how to find me. I imagine the bold text did the trick, but you never know. So you can get to me now, just in case. So now we'll dive into all these units. So there's about 1 unit per week. The source material that this was pulled off of, which is a material that focuses the Linux Plus exam, the CompTIA Linux Plus exam. So yeah, the topics that we touch on here are directly related and will get you ready for that. A lot of my students require another. Well, I don't think they require. I think the test anxiety and all of the naysaying inside of their head kind of gets to them a little bit, and they tell me they need another month or so to kind of skim through the book again, or skim through a book, skim through the material, stuff like that, just to feel more prepared. But yeah, this should cover everything that you need to know. Anyway, intro will give you an idea what to expect in the class, but these notes. So click on this. It'll take you to a Google Drive page. You can save this as a PDF. By the way, every bit of my notes you can save in any format you want to. I have it in Google Drive. Just so, for 2 things. Number 1, I make mistakes. That happens probably a lot. Some I just haven't even found yet. But this is so that I can go in and make a quick correction on anything. Makes it real easy. Saving to PDF and linking it in the course, it's such a headache to go in and change, and then you have to tell everybody that, oh no, I made a change on this PDF, go download it again, whatever. You kind of have that same vibe here, but at least I can make the change quickly. During, like, the moment someone tells me there's a mistake, I can go change it right then and there, and then everybody can download a new PDF of it. So PDF is nice. Sometimes I have images in here. PDF deals with those pretty well. You'll realize pretty quickly I like PDF a lot, mostly because it's standard across every single operating system that you can get your hands on. So it's really, really nice. And just about every word editor, what do you call that? Office suite thing, whatever, can save to PDF. So it makes it pretty nice. I will have videos. These are the old videos. These are in case I get hit by a truck, can't come in this week. I will release these so that you can see them. You cannot see them now. I have them grayed out, and that's because I'm recording the new one right now, and I will make that available to you here in just a minute. So just in case I get hit by a truck, every week has one of these, and I will release those in lieu of recording a new one. But obviously, it's not going to happen this week. So each week, you'll have 2 things to do. One is a quiz. And, ooh, hey, cool. Some folks have already dove into it. The notes and my lecture are going to be where all of this quiz stuff comes from. I will say 95% of it comes directly from the notes. You might find one or two questions maybe in a handful of weeks. Like, over 4 weeks, you might find one or two questions that come from the lecture, but likely not. They're all going to just come from the notes. That way, there's something for you to keep an eye on and study. So these quizzes don't have a huge amount of questions in them. They're really pointed, and some of them are multi. As in question number 1, there are 3 questions. So, it makes it a little bit easier to just kind of work on something. So the way that these quizzes work is there's no time limit, anything like that. They open up on Monday. On Monday, 8 o'clock, you can open up this quiz, look at all of the questions, get an idea of what I'm going to be asking you this week, and then just close her down. You do not have to submit the same day or the same hour or whatever that you open up the quiz. This is something that I want you to be working on little by little throughout the week. If you can knock it all out in an hour, then do that. But otherwise, like this. Which software packaging style does Debian and its derivatives use? That includes Ubuntu and all of the weird subderivatives like Linux Mint and Pop! OS and all these other things. So what kind of software packaging does Debian use? What package manager does Debian use? And what would you do to install the OpenSSH server package? Yes.
So, what is the expectation with answering these questions? Since it's open-ended, is it just a sentence for each, or do you need us to describe in more detail?
I do not have any kind of minimum length requirement or anything like that. I'm not grading your English. I'm not grading how much you can BS me in a single answer. What I'm really looking for is there's an extension to this. So like in this particular thing, the software packaging type is an extension. You'll find debs and RPMs and tar-gzs and all kinds of weird stuff. So the answer to this question is that's not the answer. It's not ABC. Don't put that, please. Don't submit that. But like that's enough. That's I can use that for this. That is the answer. So you don't need to like stretch it out and be like the answer to this question is the ABC file format. You don't need to do that. Just give me the answer and I'm happy with that. In the event of a question that I think there are some back here. Let's look at these. Oh yeah, see again, this is just a command. So give me the command for CentOS, command for OpenSUSE, and command for Ubuntu. So that's not. Yeah, so in this quiz, all of them are pretty much commands. So if you just give me the command, then that's fine. I don't need a sentence or anything like that. If I do end up asking a question that's not just a straight command or something like that, again, I'm not looking for. I'm not even really looking for complete sentences, to be honest. I'm really just looking to see if you're thinking the right thing. So partial credit is always up for grabs in situations like this. So if your answer is slightly off, you'll get most of the points. You'll get 3/4 of the points that you could have earned on this particular question or something like that. So good question, by the way. Did I answer it? Perfect. All right. So yeah, open-ended stuff that stays open until Sunday 11:59. So chip away at it throughout the week. You don't have to do it all in one go. And of course, those since they're open-ended, just a quick answer is fine. I don't need a paragraph, unless you want to give me a paragraph. I will say that if you kind of circle the drain a little bit of that answer, I will give you some credit for it. So adding more is probably never a bad thing. All right. And then labs. All these labs are self-contained. If you see, as we did on Monday, I want to say it was Monday. If you see anything wrong with these little download buttons were super hidden. It made sense to me when I put them there, but obviously it was a tough time finding these download links. So I made them more prominent under each distribution CentOS. Just click on this, and it'll start your download for the ISO that you will use to install these operating systems. So I don't have like notes on how to install the operating systems. The process is pretty much the same as a Windows install. I don't really have any kind of specific way that you need to install these. The default, whatever comes up in the default is fine. But I will go through, walk through some of these, so you can see what's going on. I'll pretty much go through one of these, so you can see. I had a lot of confusion over how to install a package manually and how to install a package automatically. So we'll talk about that a little bit more. But for now, that's the last thing. That is your lab. That's what you will do. Just read the instructions, do what is said. If you have any questions on what the heck I'm talking about, feel free to just reach out. Does not have to be during office hours or anything like that. Just send me a message, and I'll get back to you as quick as I can. And if it's something that is something I made a mistake on, or we just agree that it just does not make sense, I'll reword it and email everybody to let them know what's going on. So yeah, I'm totally open to making stuff better. Please let me know. All right, and next week is pretty much if you get ahead, if you're done with everything on Tuesday or something like that, and you just want to start moving ahead, just let me know, and I can start opening stuff up a little early. But as I said, it's pretty much just going to be one of these units per week. That'll be the typical cadence. If we want to move faster, we can. Just say the word. All right, well, that'll do it for all of that. Now, into this stuff. Yay. So Linux, yay. We finally made it. Finally got through all of the routine, mundane stuff, and now we can talk about the actual meat of the course. So, the basics. There are some things that are different from Windows. Most of what you have learned and done, I would imagine, has been focused on Windows, and rightfully so. Just about every enterprise that you walk into, pretty much every one of the regular folks are going to be using Windows. So the focus on Windows is important. So we'll talk a little bit about the way that Linux is put together. Everything is a file. You're going to hear that probably forever, because it's true in a sense. Everything in a Linux distribution, in a Linux operating system, is a file. Even devices, so like your hard drive, shows up as a file in Linux. Everything, your webcam will show up, your keyboard shows up, the terminals that you use to type in commands, those show up as files. And of course that includes the pictures that you download and the executable, the binaries, like we're talking about here. Come down. They're all just files. Everything is something that you can move around the operating system. You might break the operating system by doing that, but you can. So everything is a file. That theme will come up more, and that phrase will make a little bit more sense as we get through the course. But yeah, stick that in the back of your mind, and we'll pull that out every now and then. So binaries. You know these. You have seen these. You have used these. I guarantee it. In Windows, binaries look like .exe files or .msi files. They are basically just pre-compiled code that you run on your machine, and it does something. Doesn't matter what it does. It just does something. Sometimes those binaries are Microsoft Word. Think of word.exe. When you open up your start menu, type in Word, and you hit Enter, that's really what it's linked to. And the same goes with Linux. The binaries are typically stored in a directory, kind of like program files or program files x86. So, yeah, there is a direct analog between Windows and Linux when it comes to binaries. That's pretty much it. So when you launch Firefox and Linux, there is a Firefox binary. They don't get extensions a lot of times, so there is no .exe or something like that in Linux. It's if you go and find Firefox, it's just called Firefox. I've got You can do that. Yeah. So it lives in the USR bin directory, and it's just called Firefox, right? Like no .exe or anything like that. So, yeah, Linux does things little. There are little differences between Windows and Linux. So libraries. Again, there's a direct analog in Windows to a library, and this one does get an extension in Linux. .so typically doesn't have to. I think pretty much everything in Linux does not have to have an extension. It uses the metadata about the file to figure out what it is, and then just deal with it that way. But libraries tend to have a .so extension. That SO stands for Shared Object, and this is one of the real big differences between Linux and Windows. So Linux has this idea that you want to be as efficient as possible. Not that Windows doesn't try to be efficient, but Linux takes it to a whole nother level. So in your system, there are things called libraries. And this is basically shared code. It's a lot like binaries in that there's code, right? You're running stuff. And libraries live... I lost it. Typically in lib or user lib, something like that. Yeah. So these are all the libraries that you might be using in your machine. Say, take this one for instance, libcpu freak. This is a library for figuring out how to figure out or how to look at your CPU frequency. So it's used by the lscpu command to figure out this. So if you want to know what frequency your CPU is currently running at, that's it right there. On more modern hardware, that's going to change a lot. A lot of the modern CPUs tend to clock down so they can save energy and reduce heat, things like that, especially in laptops. But desktop CPUs do that a lot as well. Anyway, long story short, libraries are shared code. And if you have two pieces of software that use the libcpu freak library, then they will use this library. So in Windows, you're just given libraries for every executable that you bring in. If it needs libcpu freak, they ship it with that piece of software. In Linux, the piece of software is already installed, and everybody is mandated to use it. So yeah, instead of bringing up that library a bunch of times, you bring it up just once, and everybody shares it. That's the idea. But that's changing. The Windows and Mac way of doing things, which is just to dump the binary and all the libraries that are required into a directory, and then just double click on a thing, and then not care about storage size and all that stuff. That is taking over in Linux as well. You have these snap packages, Flatpak packages, all kinds of different things that ship you just the whole thing, all of it from top to bottom. It takes up a whole lot more disk space, but we live in a modern age where disk space is not nearly as much of an issue as it was back in the 70s. Now, that's going to be a common theme, the 70s. And I'm going to bring it up a lot because a lot of the things that Linux does came from people that created it or created Unix back in the 70s. So we're going to come up to a command. My favorite command is pwd because it means something totally different than it used to. But pwd stands for present working directory. You type it in, pwd, and it tells you where you are in the command line. It's really handy. But that P really stands for print. And it doesn't mean just like print it on the screen. It meant to literally send it to a printer. So back when Unix was shared, as in everybody logged into one mainframe, and you had these little typewriter looking things in front of you. You would type in pwd, and that command would go to the mainframe, and the mainframe would send you back a response, and that response would literally print out in front of you with a dot matrix printer. It would like screech across and screech across and screech across, and it would say this, something like that, right? Home Mint or something. Yeah, just imagine. No screens, no monitors, no nothing, but a printer, and everything you did made the printer scream at you. Yeah, weird. Anyway, so configuration files. Everything that you have in Windows App Data or program data. So there's C program data, and in your users folder, there's an app data folder that contains all the configuration of all the software that you use. The way that you have your title bars all figured out in Microsoft Word, that's a configuration somewhere in Windows, and that typically lives in app data. It's a per user thing, right? If you have 4 different people using the machine, you want all that to be customized, to be personalized for every single user. And that's the way that they will handle that. They'll put all that stuff in app data. So configuration files in Linux, the ones that affect everybody, those live here in etc. And then whatever you're talking about. So SSH is a remote control software where you can log into a Linux server and issue a bunch of commands and then log out, and then you're done, right? And that server can live, halfway across the world for all it matters, or just in the next room. And then you can make changes to the way that software behaves by looking at its configuration files. And you don't have to remember these directories just yet. We'll go over a lot of these later on. But yeah, they all live in etc. It does stand for etc. There's also a personal one. I mentioned the personal one. I don't have it written out here. But it's in home, let's say, user.config. And there's a couple other places, but .config tends to be the most common. There we go. See what I mean about making changes? Yeah, it's super easy this way. Anyway, documentation. You don't have to go too far for documentation, and this is a command you're probably going to get really, really familiar with, but the man command. So man has nothing to do with gender and everything to do with the manual. So man, command that I used a little while ago, pwd. So if you do man pwd, you get the manual for print working directory. And it tells you what it does, prints the full file name of the current working directory, tells you the kinds of options that you can use with it. Oh, I see. So -L will do symlinks. So these are like shortcuts. P will ignore them or avoid them all. --help. This is another option that you will probably get familiar with. This is the one I use more often than man, because usually it's a truncated version. So you can do pwd -help, and that'll give you some of that same man page stuff. But usually when I'm doing -help, it's like, oh, I forgot the letter option for this particular thing. I want it to behave like this. I forgot what letter means that. So I'll use help to remind myself what it is, and then you can put that command together. So these options are fairly easy to figure out. Once you've seen it once or twice, you always want to do command, option, and then any additional arguments go out here. I'll make some examples of that here in just a little bit. Because if you've never really been presented with a Linux terminal, a lot of these words don't make sense to you just yet. So don't freak out. We will go back over them all. Anyway, so you can add options like that. When you're looking at the man page, you'll see these things. That's how they'll work. Command, tell it how you want it to act differently than default. So man comes in really, really handy. You can even man configuration files. There are manuals for each configuration file, so you can figure out how to make changes to it. But that's a topic for another day. So we'll move on from now. Anyway, everything else that isn't one of those 4 basic categories is just data, right? We've talked about all of the stuff that you need to make the system run and work, and do the things that you want it to do. And then everything else is pictures, docx files, PDFs, plain text files, .txt, or no extension at all. Videos, right? MP4, M4V, all these things. Everything else is pretty much just data. So I've got some other stuff going on, showing you just where stuff is. The libraries that I mentioned before, you'll find them in lib or lib64, as I showed you before. here's the deal. There's this thing in Linux, and you're going to see this between Ubuntu and the Red Hat derivatives, CentOS, and OpenSUSE. Different distributions can put their libraries wherever they feel like putting them. No worries, Kansas. This will be recorded, and you can watch it whenever you can. So yeah, these can be used in any way, and whether they're in lib or user lib, different distributions handle them differently. There is a concerted effort now to actually consolidate all this. So anything that shows up in lib and lib64, most people just link it here. Well, they actually move the library to this directory and then put a link in lib to point to this. So basically, they're just moving stuff and then putting a shortcut to it so that you can still get to it. Older stuff might be looking for your libraries in this directory. And they really live here. But there'll be a link here. So I've got an example here. So if you're doing an ls of lib, you might see something like this. Turns out these are linked. So that if anybody's looking for this thing, they'll find it, but it'll really be this thing. Right? So just a shortcut. It looks weird in the command line, but that's the idea. All right. So if you want to get at your libraries in any meaningful way, if you want to change them or something like that, you'll use the ldconfig command. And so, by the way, just know this command. Know that it exists. You're not going to be using it much. Modern Linux systems have done a fantastic job of just handling libraries for you. I have not seen an instance of having to actually dig down and use this command. But you might want to figure out what libraries are in use. And that's where the LDD command comes in. So you can do something like, so we did which Firefox a little while ago, somewhere up here. Yeah. And we found out it lived in user bin. So we can take that, copy that, and we can do LDD. So we need to look for a different one. Interesting. Let's see. LDD bin. See if we can do that. There we go. So we'll just use a really common command, touch. And you can see it's using this library, VDSO and libc and Linux x64 64.so. So if you have a binary or something like that, and you just want to know what libraries it's planning on using, because for some reason it says, you try to run that software or something like that, and it says, library missing. You can use the LDD command to figure out what library it wants if it doesn't tell you, and then you can go out and find it. And then if you drop the library that you downloaded in user lib, you'll be okay. That will be the way that you handle it. All right. LD library path. So these are, if you see resources like this, referred to like this, just all in caps with underscores, you're looking at a variable. And in Linux, a variable can contain a few different things. Come on. There we go. So you can ask with the echo command to see what's inside a variable. So basically, you just want to see. Oh, no. Caps lock, please. You can see there's nothing stored in it at the moment. And this is because I'm running it live. It's not actually installed. So the dynamic linking is kind of busted right now. Once I get the operating systems installed, this... oh, wait. Also, It also could be because I typoed. Yeah, it doesn't have anything in it, though. All right. But to show you how it does actually work, you can do something like pwd or user. Find out what user you are, host name, different kinds of variables that you can find on your machine. Anyway, so LD library path has all of the paths for where libraries live. Typically, that'll just be /lib or /userlib, as we mentioned before, right here and right here. But if you store, say you've got custom libraries or something like that that you need to store, and your software is looking for it, you can add an entire directory by changing what LD library path means. So again, this is preliminary info. You don't have to memorize this just yet. We're going to get to mucking around with variables a whole lot more later on. But this is just good information to have to come back to every now and then if you do need it. All right, so the topic du jour, package management. That's what this thing is all about, what all of this is for. So we need to talk about RPM and Yum, and to a lesser extent, or actually to a greater extent, DNF, which is pretty much the exact same thing as everything else. So, all right. So we were talking a little while ago about MSI files in Windows. That's pretty much what this is, what an RPM file is. You can go out to a website. Let's say your business uses, I think Slack has one, right? Say your business uses Slack to communicate between everybody. Slack does have a Linux client, and if I can find the download, maybe not. Oh, come on. Oh, way down here. Let's see. Of course. Oh, you know what? Let me do it like this. And I'm running everything off of a disk because I haven't installed it yet, so things will run just a little bit slower. Crank this up a little. All right, so we'll go to Slack. I'm saving the VS Code one for the actual demonstration. All right, so yeah, exactly. So you can download the deb file for Debian-based distributions, and you can download the RPM file for, I don't want to say Red Hat-based distributions because OpenSUSE is not one of them, but OpenSUSE would use RPM as well. So anyway, if you download the RPM and you double-click on it, and you have a GUI at your disposal, most GUIs will just say, okay, cool, let's install it. And then you click install, and then it's done. So, I mean, it works pretty much exactly the same as you would expect a exe or an MSI to work in Windows. So deb and RPM, specifically because we're talking about RPM and Yum, RPM is pretty much the equivalent of an exe or deb file. And typically, this is how you'll manually install software. This doesn't happen a whole lot. Typically, most everything you will use is in a repository of some kind, but we'll talk about that here in just a minute. So anyway, the way that you install these softwares, RPM, is the command for the RPM package file. And install verbose, and I forget what H stands for. When we get to, we'll run through. Actually, you know what? One other cool thing that you may want to know is if you run that command, man RPM, in Google, it'll usually give you this website. And you can go in and find out what each of these options is. So, -H. Oh, hash. So it will make sure to hash the software to verify that it is the software that it says it is. So there's a unique hash that will match during installation. Anyway, it's basically a quick check to make sure that the software that you downloaded is the software that you were meant to get. Anyway, and then type in the package name. So you can go in and type in rpm-k or --checksig. You can do either of these, and that will look like. And then, it was big K. And then package name, whatever it was. So, I mean, in our case, it would be something like Slack if we had installed that. Or --checksig. So you can swap one or the other. These are easier to write. These make more sense. But they mean the same thing. Anyway, to verify, you can do rpm-big-V to verify the package name, or to verify that it's installed correctly. And if you need to, if you actually need to validate it, you can use the A option in there as well. To uninstall it, rpm-E. Yeah, and this is what I mean about these are a little harder to understand. -E. I don't know what E actually stands for. It may not stand for anything. Let's see. Oh, did I close it? Yeah. So let's see. -E. No. There it is. Oh, erase. Ah, that makes sense. So -E, or you can just actually use the --erase option instead. So let's say we were trying to uninstall Slack. You could do something like that. You can also do 2 dashes, erase Slack. Assuming we installed it with RPM, the command was IVH, and then you would need to do the path to install that. So it would be something. Let's say it was in your downloads folder. And it would be slack.something.rpm. That'd be the easiest way to install your software. There's some cool tricks in the command line that we'll encounter later to make that way easier to type. You don't always have to type all that much. There are some cool shortcuts that you'll run into that we will see. So anyway, yum. Yum is a command that allows you to install and update all of the packages that are on your system over the internet, and you don't have to go and do much of anything. So think of yum will mostly be handling the same thing that Windows Update handles, right? So you will type in something like, well, I don't have it in here. I will add it. Anyway, what I'm looking for, or what I want to talk about, let's see where I put. Oh no, I do have it. Never mind. It's just down further. Okay. So you can use yum. Let me just switch gears for a sec. You can use yum in the same way that you use RPM, and you can do it like this: yum install package name. So that would look like, instead of RPM IVH, it's yum install, and then home, if I can type, slack.rpm. You can do that. This is the same way. This will give you the same exact result. But most folks tend to use yum to manage all of their packages. So, yep, this is all about installing and uninstalling all of the stuff that you might need on a day-to-day in any particular distro. And then, yep, if you want to pull packages from a repository, now this is really where Linux deviates from the way that Windows historically and Apple historically have done things. So Windows has introduced the Microsoft Store, and Apple has the App Store. So things are converging quite quickly, but Linux has been doing this for the past, 2 decades, 3 decades. So, well, 2 decades, I guess. Yeah, 97, something like that. A little over 2 decades. Most Linuxes have been handling things through repositories. So think of the way that you install software on your phone. You open up a store, you search the thing, you click install, and you're done, right? This is how yum will behave. Yum is the same way. You can do yum search and then something. So you can look at this, right? Like yum search GUI, and it will find every package that has GUI in the name or in the description. That way you can find other graphical user interfaces to install. And this goes with everything. So, yum search text will find you most packages that will edit text or handle text or deal with text. You'll find quite a bit of stuff in the repositories. Once we get to Deb, I can show you how a lot of this stuff works. Yum and apt, what we'll talk about here in a minute, tend to be very, very similar in a lot of ways. So I'll show you more of a demo on that stuff. But once we get CentOS installed, I'll show you Yum as well. Anyhow, so to install stuff, Yum install Nano. Let's say Nano is a text editor. To remove it, Yum remove Nano. So real easy to do. So basically, Yum does the same thing as RPM and more. So Yum can install RPM packages, but it can also install software that comes out of a repository. Think the Windows Store or the App Store or Play Store. That's pretty much how that works. Now, in more modern versions of, let's say, Red Hat, CentOS, a lot of these distributions, Yum is deprecated, but it's still there, and every book will still reference it, and you'll still be required to know it just because it's still there. So if you take Yum, the way that we've been using it, right? Yum install this, Yum install that, Yum remove this, whatever, and replace Yum with DNF. So like this. All right, so we did Yum install that Slack RPM. Let's say we just flipped Yum to DNF. That will work. DNF uses the same options and same everything as Yum does. So we can, man Yum, we'll look at the Yum manual page. And you can see these are the common commands, right? Yum alias, Yum check, Yum auto remove. These are nice commands or nice options to do different things with installing and updating and changing the repositories, all kinds of fun stuff. We'll dive into that a little bit more later. So really the big ones are like install, remove, and list, and search. All right, those are the big ones. We can look at DNF the same way. Let's use this, and that way it looks the same. You can typically find pretty much everything in here somewhere. It's further down in it. Oh, you know what? I think I'm in the wrong part. Let's check this one out real quick. Oh, yeah, this is what I was looking for. Yeah, you can see the options are pretty much the same. They are the same. So install, remove, search, everything. So DNF just has better compatibility with the newer Red Hat stuff. So they've added some features to Yum, but they didn't really change a lot of the stuff that it used to do. So you'll use it pretty much exactly the same. There are some additional repos that are available to you. EPEL is one of them. So software that has licensing restrictions or other kinds of stuff are not enabled by default. So this is kind of like enabling a secondary store, a secondary Microsoft store that has cool software that you may want to use, but for some reason Microsoft can't give it to you. This is pretty much the way that that you'll deal with that, the enable repo option. All right. So now I'm going to show you a little bit more about what's going on so we can see how these commands actually interact with the system. So we talked about RPM, the RPM command before. In Debian-based distributions, that's dpackage, dpkg. So this, the same basic way that you would install an RPM is the same way that you would install a deb file. So taking Slack, for instance, again, so instead of grabbing the RPM, oops, let's do that in the VM. Come on. Sometimes I dislike you, Mac. you'll want to grab this one, right? The deb file. So let's actually do it. I don't think it'll work because again, I'm running live, basically running off of the CD. It's not Linux is not installed in this machine, but I will. So as I mentioned before, with debs, right? This is the way that you would deal with an executable file, right? You would download the executable, you would click on it, and magic would happen. Give it a sec. There it is. So when you do that, it checks to make sure the repositories are all there. Not repository. Libraries are all available to make this work. And then you just click install, type your password, and it's installed. It's good to go. But I'm not really concerned too terribly much with the GUI way to deal with that. So let's go to downloads real quick. Okay, so I did a bunch of stuff real quick right there. So let's break this down. So change directory into downloads. So I moved from my home folder, which we did pwd a minute ago, and that was home mint. So I just said, I want to go into the downloads folder. And you can see here, home mint download. So I just went one level below, or one level down, into downloads. I did a listing, show me everything inside of this directory. The -L says, and give me all the cool info about it, like who owns it, how big it is, the date, permissions on it. We'll talk about a little bit that later. And then, of course, there's the thing. So this is what is in my downloads folder. So we can do, yep, we didn't introduce this command. So sudo, this is basically do as administrator or do as super user. So if you ever need to do anything that changes the system, you'll likely need the sudo command. You will hear me call it sudo. I learned what it did before I learned what it meant. So I pronounced it just any old which way when a long time ago. And it just stuck with me. So you might hear me say sudo or sudo, either way, yeah. That came about because I thought you were trying to be like a pseudo administrator, right? Like a fake one. Yeah, that's not what that means. Though you can kind of think of it that way. It does still work. Anyway, so sudo, and you can use dpackage-i, and then you can do home mint, not desktop, downloads Slack. And because we're live, I'm not positive that it will work, but this is the way that the command will go. And you can see what it does. Oh yeah, sure enough. Let's see if it finishes. Wow, it actually worked. Ha. Linux, you surprise me all the time. Oh, not in the menu yet. But anyway, yeah, sure enough, you sure can launch it. Huh. Would you look at that? Anyway, that's a pretty good example of what you're going to do in the lab anyway. You will install some packages, though not Slack. You'll install VS Code, which is a really handy text editor for the GUI. Anyway, so that's how you'll install something. There was the command right there. dpackage-i, and then the path to the file. Like I said, there are some tricks that you can use to make that a little easier. Yes, sir.
So, what's the difference in using dpackage as opposed to something like apt?
We're going to get there. So dpackage is just like RPM, where all it deals with is deb packages or deb packages that you've installed in any other way. So if you've manually dealt with your software, dpackage is one way that you can handle it. But there is another way to handle that, and that will be apt. So dpackage-r will remove packages, or you can purge their configuration as well. So let's do this. Dpackage. Yeah. So you got to be really careful. The way that you launch Slack is Slack, but the actual package name is called Slack Desktop. So a lot of times what I will do, and here's one of those tricks that you'll encounter, is hit tab a bunch of times. So if you start typing something, you know that it's probably Slack this or that, you can do tab, and it will give you all of the different types of things that start with, or all of the different packages that start with SL. So you can see Slack Desktop. The one I want to remove is Slack Desktop. So Slack Desktop. This is how we will uninstall Slack from our system. Easy peasy. If you wanted to purge its configuration, so you've configured Slack in a way that you don't want, you just want to reinstall everything from scratch, you will do a -P instead. This will purge the Slack configuration. Yep. I've already removed it, so you can't do it now, but that is how you would. So you would not do R, you would do P instead if you wanted to get rid of its configuration too. All right. So the question was, how is dpackage different than apt? Yeah, it just handles debs. Apt can do more than dpackage can do. Now, there are two things that you will run into. There is apt and apt-get. So kind of like how yum turned into DNF, apt-get has turned into just apt. And it's taken a few iterations for apt to get all the features of apt-get. You will to this day still see most folks writing their tutorials or whatever using apt-get. So sudo apt-get install something. You can do home. Oh, I keep saying desktop for some reason. There. So instead of using dpackage, you can use apt-get instead. And it'll do the same thing. Really not a whole lot different here. There it goes. And actually, though, I do think... Nope. Still not. Anyway, may just take a reboot. And it might be because I'm running live, to be honest, that the icon doesn't show up. Usually, anything you install will show up in this menu somewhere. Anyway, so there's not much difference outside of just installing a deb package here or there. The real difference between apt and apt-get versus the dpackage command is that just like yum and DNF, you can do system updates with apt. So sudo apt update. This will look for all the new packages that might be available to you. So if there were updates to your desktop to fix this bug or that bug or whatever, this is, and it's going to fail because I'm live again. But after that, you can do apt upgrade to actually go out, pick up all of those updates and install them. If I could spell right. Upgrade. Anyway, so it turns out really just that apt and apt-get are more system-wide as far as it touches pretty much everything. It can update any package that has been installed, but you can also use it to do everything that dpackage does as well. So what you'll find in both of these types of distributions, the RPM yum kind, the deb apt kind, is that everybody just uses apt and apt-get and yum, and not RPM or dpackage to do most of the system administration. Let's see. Yeah, you'll run into in some situations where if you install something via dpackage, it'll say can't install this or that. New packages, more packages needed. That will queue something up in apt to the rescue. So if dpackage needs to download something from the internet, here's another big difference. If dpackage needs to download something, it won't. It can't. Dpackage will not download stuff from the internet. That's why you'll need to come in and let apt rescue you. You can say apt install -f, which will just, if there is something that needs to be installed from the internet, let's force that. So dpackage says, oh, I need this library, but it can't go get it. So then you ask apt to go get it for you. So apt is the difference there, or one of the differences there, is that apt can reach out to the internet and download files that are needed to make software run. This is what I showed you a second ago. You can install a package that way. Same way as dpackage. Yep, the apt install f is not necessary if you use apt to install deb packages. It will just handle it. That is really cool. Yeah, and then you can install software from the internet, just as you did with Yum. We did Yum install Nano. You don't need to do this in Debian-based distros. Nano's already installed, but it's just an example. So apt install Nano will reach out to the internet, download all the libraries required, and install them all, put them in the right spot, and then it'll let you immediately type in the command Nano so you can start changing things up in text files. To remove it, apt remove. To get rid of the configuration, you'll see purge here too, apt purge. And yeah, so depackage does the same thing, right? -R for depackage and -P for depackage as well. So just like with Yum, you can search, apt search. So I don't know how well this will work. Again, I'm in live. So apt, I don't know, what do we want to search? Well, I mean, let's just search for Nano, see if it's out there. Yeah. So you can see these are all the packages that have Nano in the description or Nano in the name. And of course, there's Nano. I know it's installed because of this little thing right there. I. Nifty. Everything else is purged. P. Debs are weird. That is another conversation for another day, but Debian-based systems are weird. They consider all the software uninstalled, as in it was before, but not anymore, which is weird. But yeah, that's nothing you need to know. Anyway, update the system with apt update to get a list of new updates, apt upgrade to act on that. To say, yep, I see all these upgrades. Now it's time to actually install them. So this will update the list. This will install the updates themselves. Then, yeah, if you have dependency issues or something like that, because, you know, there's a new package that requires a newer version of a library that you have, you can use apt dist upgrade. I'll write that out, actually. Let's do this. There we go. Apt dist upgrade. That will install any you know, dangling dependencies, anything that the software requires. It will do that. It will figure that out for you. So the way that you will find your repositories in a Debian-based system, they all live here. Etsy apt or Etsy apt sources.list.d. So let me see. There it is. So cat is a way to just dump out the contents of any file. And so I'm looking for, in the Etsy apt directory, there's a sources.list file. If you look at that, the only source here is the CD, is the DVD-ROM that I'm actually using to run the system to show you all this stuff. But as you install it, I've got a screenshot down here. This is really what it looks like. So for a Linux Mint system, you'll get this repository and that repository and that repository and that and that. So when you do apt update, it's really looking here. These are the places that apt will look to find new software and all of that. All right.
So, what's the difference between Echo and Cat?
So Echo, yeah. So Echo basically asks the system to tell me something about a variable, or really just to echo something back to you. So you get you can end up in this situation, or you can echo. But really, a lot of times, echo is used to look at variables. Yeah, something like that. So PWD is a variable that stores this information, and it updates every time you change a directory. It will change with you. So it's dynamic. It changes. Cat, on the other hand, is meant to just dump out the contents of a file. And a variable is just a name that contains something stored in RAM. And cat will not give you the contents of a variable, but it will give you the contents of a file. So if you're looking at a text file or something like that, cat will be used. Echo will not show you the contents of a text file or anything like that. So yeah, echo for variables for the most part, and cat for files. There we go. Added a little bit to that. The files in etc apt or etc apt sources list.d typically have a .list extension. All right. So you can use, so in the command line, you can still use some text user interface stuff. Aptitude is one of them. I don't know that it's installed. Oh, it sure is. So this is a way that you can use your keyboard. It's still keyboard driven. But this is a way to not have to type a command out for absolutely everything. So you can see, let's see, not installed packages. You can go into the admin category under main, and you can look through. You need AppArmor or stuff like that, right? Use the back arrow, or the left arrow, sorry, to go backwards, to fold these back up. Oh, I see. Cool. So, and these tasks are basically if you want to do something in particular, but you don't know the different types of package names or something like that. So you want OpenSSH server. These are all of the packages that relate to that. But you won't find a whole lot of aptitude on the test of any kind. You'll see apt, the manual way to do it. Anyway, so Q to quit. If you get in there to poke around or something like that, hit the Q key right there to quit. So aptitude can typically do just about everything that apt can do as well, but it's got a cool text user interface to go with it. All right, so RPMV is a really cool option in that RPM. So now talking about CentOS and OpenSUSE and all this stuff, RPM has the option V, as we mentioned before, but dpackage does not have that option. So there's no way to go just and say, you know what, I want to verify absolutely every single one of the packages that I've installed on my system. RPM has an option for that. Dpackage and apt do not. You will have to install something separate called debsums to get the same functionality. So this is not on the test. This is just, I've had this question before. What's the alternative to RPMV in dpackage? There isn't one. You have to install debsums to get that to work. All right. We're coming to the end, I promise. So Zypper in OpenSUSE, you will encounter that. And, it does the same thing as Yum and apt. So to skip ahead a little bit, OpenSUSE handles RPM packages as well. So everything that we talked about before, RPMV, RPM IVH, RPM, all that stuff, that will work in OpenSUSE as well. But they don't use Yum or DNF. They zypper instead. So to search for things, zypper SE, or you can actually type out search. To install stuff, zypper in, or type out install. To remove things, zypper RM, or remove. To list repositories, zypper LR. I think it's --list repositories. We'll look when we get into OpenSUSE. And to add a repository, zypper AR. Now to add a repository in Linux, or in Ubuntu derivatives or Debian derivatives, you'll have to come in here and add another one of these lines. And then, yeah, went through that pretty quickly because quite literally it's the same exact thing, just with different names. So compiling software manually. This is something that you pretty much never do anymore. You can do it. There's tons of software out there that just don't have binaries, right? You can't just go grab a binary and then run it like we did with Slack. And yeah, there's just no way to run it just out of the box. So what you've got to do is make your own binary. So you download the source code, you configure all of the libraries and everything required to handle that, and then you make it and make install. Okay, so here's the deal. Here's what you're really doing. So every single piece of uncompiled software. So if you've heard of GitHub, that's mostly what's out there. GitHub holds a lot of uncompiled software. Sometimes the software developer is nice enough to go and compile that stuff for you in a generic way and then just give you a binary package of some kind. So then you can just go download, the RPM or the deb or whatever kind of binary package they've got. Sometimes that comes in app image format or something like that. But anyway, long story short, a lot of that software is not compiled for you. There's no binary for it. So you have to make your own. The way that you will do that is, in the case of Git or something like that, you will git clone, and it'll copy all the stuff in the Git repository to your local machine, or you'll grab one of these bad boys, tar.gz. This is the I won't say Linux native, but it is the most common format that you will find packages in or code in. So you'll download one of these, extract it all to a directory, just like you would a zip file of any kind. And then in that directory, you have configuration files. But you don't necessarily have to look too terribly far into that. A lot of those configuration files are already handled for you. So all you got to do is just run this command, /configure. That will invoke the configuration script and get everything ready for the next step. Make will compile the software. That's the idea. Right? All that code, all that Java code or C code or whatever kind of code, whoever, Rust, I don't know, any language, whatever that is, as long as you have the tooling for it, make will then compile the software and give you a binary, and then make install is the last step, and it will put that binary in one of those directories, as we were talking about before, right? We said binaries are like Firefox and Nano and VI, and those things, those binaries typically, as we did, typically live in user bin. So what make install does is it really just copies the binary that you compiled into user bin. That's typically what it does, or user sbin. There's more directories that we'll talk about a little later on, but that's the idea. So get everything ready. Compile the code, put that binary in a place where the system can find it. Those are the 3 steps that you'll go through to compile your own software. But again, like I said, you may at most get a question about, what invokes the configuration script when you're compiling software manually or something like that on the test. They won't typically make you go and compile your own software and do this whole process. More just questions about what these commands do. All right. So if you like to forge out on your own, by the way, that'll do it for all the stuff I need to tell you today, as far as notes go. So if you want to strike out on your own, download all your own stuff, you can do that. All of the websites are here. So Ubuntu, you can download the software. You cannot get these. There are not a whole lot of differences between the version of Ubuntu that I'm having you use, which is 18.04 and 20.04. Likely, they will be pretty much identical in everything that we need to do, outside of software that may be installed by default in 18.04 is not installed in default in 20.04. So there'll be little trip-ups like that. So the easiest thing to do is obviously use 18.04, which I've linked to you, or you can just Google it, Ubuntu 18.04, and it's right here. So go to releases.ubuntu.com. You want the server install. So come down here. Server? Nope. It's not there. Well, click on this then. Oh, there it is. Okay. So anyway, I've already got it downloaded, so I don't need to do that. Same for CentOS. Download CentOS Linux. I apologize in advance. This image is massive. Massive. If you've tried to download this, you have realized it is like 8.5 gigs. I am sorry. This is not great. I am sorry about that. Anyway, you want the x86 64 version. Click on that, and it's just going to give you a big old long list. It knows that you're in this area. click one of these under the green banner, and it will start your download. Oh, it won't start your download. Oh my God. Yeah, just look for the 8 gig file. Click on that. If you're doing it manually, I've linked it to you in the class, so you don't need to do this. And then OpenSUSE. You want Leap. Leap is the one that typically goes on servers or machines that you never, ever, 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 ever want to think about changes. So if you click Install Leap, you go grab the DVD image. Again, huge file, but not nearly as big as CentOS. We could use the network image, but I don't know. A lot of folks feel comfortable in the GUI, and I want to give that GUI to you so you can at least have some comfortable place to stand while you learn all of this other crazy command line stuff. Okay, so the only other thing that I haven't really covered in the lab is how to install these operating systems. So if you're using VirtualBox, that is what I will be using in all of the classes to show you what's going on, what's working, how to do this, how to do that, whatever. I will be using VirtualBox. You can use whatever you want. You can use Hyper-V. If you're on a Windows machine and you've dabbled with WSL2 or something like that, you already have Hyper-V installed, then just use Hyper-V. I'm okay with that. All I really need is, for each VM to have a couple of CPU cores, a couple of gigs of RAM, and 20, 30, 40 gigs of storage if you can spare it, as much as you can spare, really. That's pretty much it. So Hyper-V can handle that. VMware Workstation can handle that. VMware Player for free can handle that. VirtualBox can handle that. And I don't know if you're crazy enough to run Linux. KVM can handle that. GNOME Boxes can handle that. There's a lot of options. You can use anything. I don't really care. My focus is on the inside of the VM. But one of the more popular solutions is always good. If you are in doubt, if you're like, I don't know any of these hypervisors well enough to just forge out on my own, go get VirtualBox. Head to virtualbox.org. Download VirtualBox. You'll find this is what you want. 99% of you will likely click this link, Windows hosts. 1% of you will click Linux OS 10 hosts. And then, I don't know, there may be one. There may be one of you out there. And you'll just install it through your repository, through apt. So apt install VirtualBox, and that'll just handle the whole thing for you. You don't have to worry about it. That is one of the many reasons I do like Linux. A lot of this stuff is already just, handled for you. Okay. So let's say you've downloaded one of these ISOs, and now you're ready to start your VM. This is really all I require of you. The hypervisor doesn't matter, but this stuff does. So in my case, I will start a new one. Let's just call it CentOS. It is a Red Hat derivative, so this is VirtualBox is smart enough to know this is the version to choose. Otherwise, the OpenSUSE is in here, which we'll use, and Ubuntu is in here, which we'll use. So if it doesn't automatically select one, you can. To be honest, it's not that big a deal. If you choose Red Hat and install Ubuntu on it, it is not that big a deal. Don't worry too much about that. But it does help you visually distinguish them. Right, Red Hat is a Red Hat. The OpenSUSE one has a little lizard tail because that's their icon, their logo, and Ubuntu obviously has the Ubuntu logo. So you'll see that. 2 gigs of RAM at least. Yeah, GNOME is heavy on CentOS. So the more RAM that you can give it, the better. And then a virtual hard disk. It's going to tell you 8 is the default. That's fine, but we'll change it as we go through. You do not, here, let me start that over. So yeah, it's going to tell you 8's the default. Create, you want to create a hard disk for sure. Create that. VDI is fine, leave it as the default. Dynamic is fine, leave it as default. And here, this is just so you know where your virtual hard disk is located. In case you need to back it up, this is the file path to it. But here, we want to crank that up a little bit. I don't care if it's, 20.1 gigs or 19.8 gigs. Just get pretty close to 20 gigs. And the easiest way to do that is to just type in literal 20, and that'll handle you. And from there, create. But there's one more step. we got to do. We handled RAM, we handled disk, but there was no option for us to handle CPU. In I think in VMware, in VMware Workstation, you can do it during the installation process. In vSphere, in VMware vSphere, you cannot. You also have to go out and make that change after the fact. So anyway, go into the settings of the VM, right-click on it and hit settings, or highlight it, come up to this big old cogwheel up here. That's it. Come to System. It'll look a little different. I'm on a Mac, but the option is the same. Go to System. And you'll see RAM here. You can go to Processor. Right here. Crank that up to 2. The more processors you give it, the better. But do not enter the red zone. I imagine you have used a VM before and you've gotten this lecture about not putting things into the red zone. Basically, the physical cores that you have. So in this machine, I have 4 cores, 8 threads. But VirtualBox sees it as 8 whole CPUs. However, it does notice that they are not physical. They are virtual CPUs. So in the green zone, I can give up to 4, which is the amount of physical processors I have in the machine. But it will let me go further, which is not a great thing. You run into weird issues when you get up into this area. So stay in the green. Whatever you do, stay in the green. So 2, if you can spare them. Hit OK. All right, that's it for the preliminary getting ready. So let's start it up. First thing it's going to do is ask us, what do you want me to install? Give me the ISO. So in VirtualBox, you have to add it to a list. So add, and then find your ISOs. I think, where did I download them to? See if it's in recents. No? I know I had these things downloaded.
So we're probably going to be using VirtualBox for this class?
You can use whatever you want. I do not mind one way or the other. But if you want to stay as close to me as you possibly can, so there's no question about how do I do this or that, then yes.
Okay.
Yeah, it's right there. It's called CentOS. What the heck? Downloads. Oh, I just scrolled right past it. Okay. All right. So find your CentOS ISO, hit open, and it'll show up in this list, and choose it. You'll see it listed here. Just verify that it's the right one, and then hit start. All right. So arrow up and down. Test the media and install. That's probably the safest route to go to make sure that the download that you have, because it's 8.5 gigs. I'm sorry. Actually downloaded correctly. I'm gonna skip it in the interest of time. Gonna try to get one of these done so that you can get started on your lab, and then I'll come back. I'll come back at our 2 o'clock meeting to show you how to install the other 2. All right, this will be slower than a normal boot because it's reading off of your hard drive, reading the ISO file, having to extract it, and then shove it into RAM and then add it, or run it through the VM. So it'll be a little sluggish until you get it fully installed. But the install is fairly straightforward. If you've installed Windows, you can handle a Linux install. It does ask you, at least CentOS and Red Hat tend to ask you all the questions on mostly one page. But this is what you'll run into. Ubuntu and OpenSUSE do not do this to you, but this is just because Red Hat and CentOS do not ship the VirtualBox drivers within the kernel. So basically what you've got to do is when you click inside of here to start moving your mouse around, it's going to ask, do you want me to capture your mouse? Before you click capture, note this. Mine says left command. Yours will likely say right control if you are on Windows. That is the button that will help you escape. And you will, I don't know, if you don't pay attention to this a little bit or whatever, you will be in a panic because you cannot find your mouse and your mouse won't come out and you don't know how to deal with it. This button is gonna help you. But tell it to capture. But notice down at the bottom, look at where my mouse is now. It's listed for you right there. So it does say left control, or left command, I'm sorry, at the bottom right of this VM screen. So it reminds you. And if you, so notice my mouse is kind of floating around, but it won't leave the box. It's stuck in there, right? So hit the left command, well, in my case, left command, in your case, right control, and there, your mouse is loose again. So just be aware, this button right here is super duper important for CentOS. All right. And I'm just going to say don't show this message again. But do remember, that's the key that helps you escape. Left command in my case, right control in your case. I think it's the same for Linux if you're crazy enough to be running Linux. Right control is also for that. All right. So, English, unless for some reason you prefer a different language. Hit continue. And here we go. So this is what I was talking about. It usually asks you a lot of different questions here, but instead of doing it in multi-window, let me just make sure that... Okay, cool. I just wanted to make sure that I didn't have y'all do something crazy. All right. So keyboard English, language English, time and date. This is what you'll need to change. Come over here, and Chicago's right about here. Chicago's time zone, the central time zone. And that'll get your clock correct. Hit done up in the top left. Don't mess with any of the software. You don't need to. Local media, meaning the ISO that we inserted, and software selection is server with a GUI. This is what you want. You leave that alone, and you won't have any issues. You can add some software if you would like, but don't remove anything from this section. Then installation destination. So click on this, and it's already figured out for you. You don't really need to do anything. You do need to come in here to verify, but you don't need to change anything. It's already got a check mark right here on the disk that we created. So nothing to do. Hit done. Kdump is instances where the Linux machine crashes. This will keep a dump, a log of the dump that happens at that time, so you can go back and take a look at why it broke. So. Network and host. You want to turn this on. Network is off by default. It is a security thing. If you're bringing up a machine, sometimes you want to get it configured properly before you get it on the network, especially if you're connecting it up to a hostile network of some kind. And by hostile, I really just mean like the internet. You don't want no firewall or anything like that on it. So in this case, though, we are behind a NAT router. So we get some semblance of security, but NAT ain't a firewall. So just just note, in an enterprise, you will likely leave this off during install and turn it on after. So anyway, we can flip it on. It should automatically grab an IP address and all the other info. Name it down here. Hit apply. And it'll tell you right here, it changed your name. And then hit done. Now, we don't need to apply a security policy, but these are pre-built security policies. So if you come in here, oh, they used to have them. Oh, okay. Well, they used to have a bunch of different ones in here. It would be like the DoD security policy and all these other things to help enterprises that use a common set, like PCI DSS or something like that. A common set of rules or regulations or laws or something like that. This will get your server configured up to it automatically. So I imagine you can just Google up Red Hat or CentOS security policies and then slap the URL in there. But they used to have a list. That was very convenient. Anyway, set your root password. This is the main super user account. Root can control everything. It can even delete the entire system out from under it. So you want to have a good password here. And then you'll want to create your own user as well. So this will be where I come in. Make yourself an administrator. That way you can run commands with the sudo or sudo command. Do administrator things. Oop, give yourself a password. Hit done. Oh, there we go. And that'll do it. So the only real things that we needed to deal with was time date, the drive you're installing to, turn on network and change its name, and then set your passwords. That's pretty much it. Hit begin, and now it's off. It'll do its thing. It's going to take a little while. All right, so back on topic for a second. CentOS installed. Reboot. Right down here. Give it just a little bit. And there you go. When you see the old, ugly text style right here, you're right where you need to be. Leave it there. Hit enter. And eventually, it will drop you into a login screen, same as you would find in Windows. And once you log in, you find what's called the GNOME desktop. Yep. I think it doesn't matter anymore. The developers have decided that the G doesn't matter, but back in the day, and if you ever get into a Linux forum, someone will definitely tell you that it's GNOME, not GNOME.
Absolutely no.
You do have to accept the license agreement, which is everything is GPL2'd, which is, hey, CentOS would not exist if that were not the case. So hit OK. That basically just means that everything is open source. You can copy it and redistribute it, but if you make any changes, you have to also make those changes public. So anybody else can download and redistribute your packages or whatever else. Whatever else you made changes to. All right. Let's click on your name. Type in your password. Enter or sign in. I'm going to show you one trick that will probably prevent a lot of frustration. This window is tiny. So what we want to do is to make that window not so tiny. So the first thing that comes up is this welcome screen. You don't really have to do anything with it. Just next on through it. You don't need to make any changes. If you're privacy conscious, you can flip this off. Hit next, and you don't need to tie anything together. This is not really the purpose of any of this, so of this class. So skip that and start. It'll drop you another window. Get rid of that. Getting started. Those videos are actually kind of interesting if you want to learn how the desktop works a little bit better, but they're not required for the class for sure. All right, so under activities, I think you can get to displays. That's what you want right here. And then right here, resolution. Change this to something not 800 by 600. I usually go here. 1440 by 900. Take note of your own actual resolution and make sure you don't go bigger than that. Otherwise, the whole VM will flow off the screen and it'll just be a pain to get it back. So hit apply. It'll make that window a little bit bigger. Make sure you keep those changes, and CentOS will likely remember your settings. So from here, close this window. All right, so just to kind of finish up and wrap up, I've given you the information you need to put this together. I am happy to help if you have questions. Oops. No, I wanted that page. All right. So to update, in the notes and during the video earlier, you heard me talk about how to update RPM-based distributions. CentOS is one of those. So take a look at the notes or recall how to do that. So update your entire system. The whole thing I want you to do is to grab all the newest, latest security patches and software updates and all that stuff. Do that. And once it is done, at the very bottom of it, it'll say, you know, process complete, so-and-so megabytes, something, something. Take a screenshot of your terminal. And by the way, all of this is done in the command line. To get there, oops, go to Activities, hit the terminal, and now you can worry about updating your system. So run the command to update the system. Now install a package manually. What I mean by this is if you go to VS Code, their website, it will likely detect what operating system you're on. I hope, with all this running, I hope my little CentOS box can handle Firefox. We will find out. Man, it is struggling, and this is why I don't use GUIs in a VM. So I don't have the link. It's a little harder to share it, but it's code.visualstudio.com. So when you go there, that's the link I have in the lab as well. Yeah, right here. It gives you a deb or an RPM. So this is the same scenario that I had earlier in this video where we were installing Slack, whether you get the deb or the RPM, right? So, I mean, it tells you. CentOS is a Red Hat derivative, so you're going to want the RPM. This will likely give you some hints. If you pick down further, you'll realize that's OpenSUSE as well. And then deb for Ubuntu. So you'll get the same page on all three distributions. But the whole point of this is I want you to download this RPM and then install it through the command line. So I went through that process in the Linux Mint VM that I had up a little while ago. But you know, notice where you are. Run the ls command to figure out what stuff you've got in there. Firefox always downloads junk to the downloads folder. So you'll cd into downloads, and please pay attention. Linux is case sensitive, so that capital D downloads better stay a capital D downloads when you reference it. Otherwise, it will not work. And then once you download the file, you can LSL to find it here. Let me see if I can get this. Download the RPM. Yeah, that mouse is really slow. I'll try to not make you guys do much in CentOS and the GUI. Oh, what? Let me see. So Debian Ubuntu-based deb, Red Hat. Oh, it makes you install. Okay, here's what I'm going to need you to do then. Other binaries, VS Code download page. And then come down here to grab the RPM. There it is. Okay. So make sure you get the RPM. Follow along with the video. Obviously, it will show you how to get the RPM. If for some reason you can't get the RPM, please let me know. I will help you get the RPM. So you'll have to do this on CentOS and on OpenSUSE. So do not install the repository. That's not really what I'm after. I just want to make sure you can install an RPM, and that's about it. So for OpenSUSE and for CentOS, you'll need to go here first. VS Code download page. All right. For Ubuntu, I do think it just takes you straight to the deb. You may have to actually click this. Let me see if I click it. Okay, yeah, when you click that, the deb will go. So for Ubuntu, this is what you want. All right. So install that using the command line. So reference the notes for the commands for that. And then install a package, like a regular package that comes from the repository. So as we were talking about dpackage and RPM, those are ways to install local packages, but apt and yum and zypper are the ways to do that automatically. So depending on the distro that you're on, CentOS, OpenSUSE, or Ubuntu, it'll be, apt install, yum install, or zypper install htop. So you'll need to reference the notes, find out which one CentOS uses, and install htop. Anyway, the other two distributions are exactly the same thing. Ubuntu has one additional step because when you install via the Ubuntu server, it does not give you a GUI out of the box. So the first thing you got to do is go and install the Ubuntu desktop package. And it'll be the same way. So whether it's apt-yum or zypper, use the proper one to apt install or zypper install or what's the other one? Yum install Ubuntu-desktop. So whichever one Ubuntu uses, use that. Install that package. But I'm going to do another video, and I'll show you how to do that because I'm not really testing you on this at all. Just more a reminder to do it. Okay, well, I'm going to stop the video here, and we'll pick this back up after lunch.